What's going on, everybody? I'm Anthony with IAG, and today we're going to talk about what IAG short block is right for you. Alright guys, since I'm not an expert in our engines, I'm not going to try to be, learn here every day. That's one of the things I love about working here. Decided to bring in the head of our engine department, Mr. Jim Justice. Jim, thanks for coming on today and taking the time to do this.
You're welcome. I appreciate this very much. Hello everybody. A little background on me is been fortunate to be involved in high performance racing and engine building for my entire life.
Nice.
And chance meeting with JJ at a point where he was deciding to start an engine department, and we made a deal, and 6 years later here we are.
Great. Happy with the results?
Yeah, it can't be better. No place I'd rather be.
Nice. All right guys, so when picking your block, you need to ask yourself a question of what's your power goal for the car, and are you ever going to want to expand on it down the road? We offer anything from stock horsepower to about 1,000 plus horsepower. That's correct, right, Jim?
That's correct, Anthony.
Okay. When someone's looking at, say, our stage 1, and we say we rate that to 500 brake horsepower, we're measuring that differently, obviously, than people saying, hey, I make 500 wheel horsepower. What's the difference in the two, brake horsepower versus wheel horsepower?
Right, brake horsepower is actually measured at the flywheel. You're measuring strictly the horsepower of the engine itself, whereas wheel horsepower, you have power going through the transmission, the drivetrain, different size tires, so that could result as much as like a 20% loss relative to the brake horsepower figure.
Okay.
And each dyno is different.
Gotcha. We're going to go over our stage 1, stage 2, and stage 2 Tuff blocks. These are our open deck blocks. But first, we're going to have Jim take us through the engine department to show us the building process for any of our stages, to show you guys the quality and control that these guys take when building these. We often have had questions from you guys, has our quality gone down since IAG has grown as a company? And that's definitely not the case. It's only gotten better. So let's go ahead and take a stroll through the engine department. Before we go through the engine department, we're stopped out here at our Centroid machine. Jim, tell us a little bit about the Centroid.
So the Centroid we're using for all of our CNC port work. Something new that we brought on recently is our stage 2 and 3 cylinder heads, which are all pocket port based, as an addition to our stage 4 and 5 full CNC ports.
Okay, and looks like we got something running in the machine right now.
Yep, yeah, we got a set of EJ heads in there right now, running full port.
Our first stop, we're in the cylinder head room. Jim, explain to us what goes on in here.
All right, this is as far as obviously cylinder head work. You've seen where we machine the cylinder head as far as porting goes in here. And they come into the cylinder head room and now go to our newly acquired new one Contour seat and guide machine. Guides are installed and go into the new one to be reamed for size. Then the valve job is performed on that. We have different stations so that each one's dedicated to a certain procedure, and we're able to do a large volume of just the same thing all the time.
Okay, so we keep it consistent that way.
Correct, correct.
Doing the same thing over and over every day, you just...
Right, we got the seat and guide station, that's all that happens there. Obviously, with the seat and guide machine, as far as cutting valve seats, it's the only thing that happens over there in that area. Then it moves on to its next step.
Okay, great. Next room we'll go into is the bore and hone.
Yeah, it's going to be bore hone room where all the block work takes place, as well as connecting rods.
All right, well, let's go. Now we're in the bore and hone room. Jim, take us a run through of what goes on in here.
All right, one of the operations that happens here has to do with the connecting rods, and we have two machines for that. As far as our base Sunning machine, which do single rod sets of rods. Our latest addition is Sunning SH4000 Power Stroke Hone. We have this set up to do big and small ends of both the FA and the EJ rods, and gives us very precise controlled finish and sizing of both the big and small end of the rods, and all the rods pass through this.
Okay. Now, before we had this, what were we doing?
We were using the small machine over here, which one rod or a pair of rods at a time, so obviously this takes longer.
Okay.
Yet, the results are the same, yet this is able to run through a pallet of rods at a time.
Oh, okay, great. What do we have Joe doing over here?
Joe right now is at the ring grinding station. There we have 4 ring grinders, which are set up to do our top and second rings in both the EJ and FA platforms.
Okay.
And we have setting jigs because we have control over the final bore size. So we're able to, final fit our piston rings at the gap per stage.
Okay.
In these setting jigs, and they're literally a full set of pistons, full set of rings, and they can go and assemble for that particular stage.
Oh, okay. Now, is each one that he has over there set up to do a different ring? Or?
That's correct, yeah.
Okay.
So there's 2 per engine, maybe the FA and the EJ, and of those 2, one is for a top ring and the other is for the second ring.
Okay, great. For the cranks here, what do we have him doing?
Okay, this is a new addition for us. It's really done a lot as far as increasing production and also actually increased measuring precision for us. All it is now we're using air gauging.
Okay.
Check the diameter of the journals and roundness compared to hand micrometers.
Okay.
So as you can see, we're able to move down the line very quickly. It's the most precise method of measuring available.
Okay.
Helps eliminate the human part of using an outside micrometer.
Okay.
So your eyes able to go down this list of cranks, write down all the sizes, then it can move on to the station where rod bearing clearances are set, and again further down the line when it comes to setting the main bearing clearance. They already have everything measured, and it's all zeroed against the other gauging equipment we have in here.
Great. Okay. So another thing just to speed up the process, I guess.
Absolutely, and the accuracy.
The accuracy.
It happens very quickly. We saw he just measured, crank literally inside of a minute.
Whoa!
This is the SV30 CNC controlled cylinder. What we've done is modified it so that we can run 3 blocks at a time.
Okay.
So we do match up with what we're going to put in there, like we're going to do 3 stage 2 Tuffs at a time. We know what bore size we want. Because our pistons, as manufacturer, are very tight, controlled as far as sizing goes. So we can set this and literally walk away. We'll do all 12 bores, and we take those out for the next 3 in.
Okay. Now, before we had this machine, what were we doing before this?
We were using our SV10 to its right. And we also, again, had modified that to do 2 blocks at a time rather than just single. So again, we're doing multiple blocks, which obviously, at the same size.
Okay.
So we're trying to be as efficient as possible, but then you had to stand in front of it. It's not fully automated as this machine is. It's literally push the button, start this, and walk away.
Walk away. Okay. That allows them to continue on down the line and get more things done.
Correct. Now, we've done as many as 28 to 30 blocks a day in this machine.
Wow. Okay.
So we should keep doing this.
How many could we do in that?
On a good day, you get like maybe 8 if you're hustling.
Okay. So definitely more than double now. Yes. Great, great. All right, Jim, so next we have, this is our line hook.
That's correct.
Okay. What do we do?
Its purpose is to size the main bearing tunnel.
Okay.
So we obviously know what kind of clearances we want to run, and we know our general size and range of the crankshaft main journal diameter.
Okay.
And we obviously know roughly what our bearing thicknesses are. So we actually have an OD that we target for all the blocks, so that we kind of know that, as it gets through the assembly process, that we're going to be within range on the bearing clearances for each of our stages. So this machine does that. It uses a mandrel with honeystones in it, and we use non-traditional type mandrels in this process here, and yields actually a better quality, straighter bore compared to normal mandrel.
Now, do we do this for every stage?
We do this on our stage 4 and up.
Okay.
Anything that use like the ARP case bolts.
Okay.
And we do check everything, even down to the stage 1. If there's an issue, we'll obviously run it through it. But the stage 1 and 2s, 2 Tuffs through stage 3s, as the case comes. The OE is actually very, very good and very, very close.
Okay.
There's no need to touch it.
So for our stage 4 that you said we use this for, we're opening that up for more.
No, we're actually converting the bolts from the OE case bolts over to ARP brand case bolts, and the torque and clamping of those bolts distorts the case, and so the tunnel needs to be corrected.
Gotcha. Okay, makes more sense. Like I said, guys, always learning, always learning. All right, so the last station we have in this room, guys, is the rod assembly.
Yes, we call it the rotator station.
Okay.
It's basically the crank and the rods as they need to be assembled and then dropped into the case. So here you can see where we have crankshafts that have already been measured using their air gauging system.
Okay.
And you know, he pulls out sets of rods, multiple sets at a time, gets those all measured and loaded up with bearings. Again, you can see here that I mentioned earlier, here's how we receive bearings from HTL.
Okay.
There's 80 sets of shells in each of these flats, and we actually break these down. You can see on where he has literally laid them out in our subgrades, so we know, you know, and have control over our final bearing clearances.
Okay.
So we're able to, you know, sort through this very quickly. So as far as after the assembly of the rods onto the crank is done in batches, and then set in our fixture here where the rods are, you know, stretch torqued and set over on your shelf, so they've been labeled as to what stage they are. And, you know, in final assembly, when they come and pick up their block, they grab the appropriate rotator and set of pistons and head off into the final assembly room for final assembly.
Okay, so for final assembly, first step we do is what?
Okay, they picked up the block, and our next step is to set the main bearing clearance.
Okay.
And again, like we do with the rod bearing clearance, we also, here's how we receive our main bearings from ACL. There are basically three different styles. We have our flange thrust bearing, and then we have the wide and the narrow individual bearings.
Okay.
So again, we're able to measure these. They've been laid out as what our subgrades are.
Okay.
And we're literally able to take up, you know, what they think based on the crank size, set of bearings to put in the case. They torque it together and do a physical measurement of the bearing clearance. And once that's okay, then the block and its rotator, pistons and all are, you know, grouped together as a kit.
Okay.
And then it goes to the other side of the room here for final assembly.
Okay. Let's head over there. The bearings are set in and torqued. We then come over here to final assembly for rotator going in.
Correct. Yeah, what we have here is our basic kit where the you know, case abs already have bearings in it, so it's essentially split. Bearings are lubricated. We have a rotator here with protective caps on the small end of the rod so it doesn't scratch the bores during assembly.
Okay.
That gets dropped in, cases sealer put on, put together and torqued. The piston rings, which have already been final fit, are already on the rings earlier as we're producing our kit. So literally all the assembler is doing is double checking everything's installed correctly, lubricating all the parts, and just start assembling.
Okay.
They don't have to do any measuring. All that's been done and fitted before.
All he's doing every day is just the final assembly, putting the rotators in.
That's correct. We run a production line assembly, so we have stations for all of these things so that you're not doing one thing, put all your stuff away, and then the next one comes and you go and do that one, put all your stuff away and start over. So we're as close to a CNC operation as you can with human beings, is what it amounts to. And it also helps with quality control as far as, you know, they see the same things, they know something, you know, comes by, doesn't feel right, doesn't look right, you know, we catch that.
Now, with the process that we do, how many blocks are we able to produce a day, a month? What kind of numbers are we looking at?
What we look here for is a daily production, you're right, with the number of people that we have here and the machinery, you know, and things that we've improved along the way. Right now, our target is 10 a day. 10 a day. 10 short blocks. You know, and we, you know, obviously improve process and continue to do that, you know, allow us to produce numbers without sacrificing any quality at all.
Fucking A, man.
All right, well, let's go back into the studio and start going over our stage 1, stage 2, and stage 2 Tuff blocks.
Sounds good.
All right. We're going to go ahead and step into our stage 1 block. Jim, what goes into building one of our stage 1s?
Stage 1 is actually based off of, you know, stock production components other than the pistons themselves, which are known to break in normal use. You know, we do take the parts such as, you know, the crank rods and block, and we do QC those. The block does get honed for a 99.5 drop-in piston of our own design with JE, uses stock OE rod and crank, which are QC'd and, you know, to our blueprint specs before final assembly.
Now, what's the difference between our stage 1 piston that we use versus a stock piston?
The stock piston is a cast piston. You know, it's designed for street use to, you know, run for 200,000 miles, is, you know, without any troubles. But
At stock power levels.
At stock power levels. You know, obviously we're in the performance world and we start exceeding design, which leads to traditional crack ringlands.
Okay.
And, you know, so we've come up with a piston as a replacement at the same stock bore size.
I'm guessing still the stock rod is strong enough to handle our power levels that we're going to output with a stage 1 block.
That's correct. There's no reason to change it at this level as far as the design goals for the stage 1.
Okay. For the stock rod, is that a cast material? Is that what differs from then stepping up for our stage 2?
While it looks cast, it is actually a forging, as are most OE stock rods. It's a very cost-effective, strong rod for its intended use.
Yeah, I mean, comparing it to would go into our stage 2, it does look like it has thicker material, but obviously not as wide of a rod.
That's correct. You know, we have an I-beam is what the stock connecting rod shape is,
Okay.
which is easy to make, versus the H-beam, which is harder and requires more machining to make.
Okay.
Yet that the H-beam design is stronger by design. So
Okay.
when we start exceeding the power levels of the OE I-beam type rod, which you can see, you know, very small overall compared
Yes.
to the H-beam that we
Okay.
use.
H-beam and I-beam, how come some people say I-beams are better or H-beams are better?
Okay, and this applies not only with the OE rod versus even in the I-beams that we use in our stage 3 and above short blocks. The I-beam is a stronger rod when it comes to its, you know, running compression loads, whereas
Okay.
the H-beam is very strong as far as, you know, high torque, low RPM. Problem with the H-beam rod is when we start putting serious horsepower to it, is the flanges here will actually start to bow out.
Okay.
And then you have some issues with the shape around the small end and its strength. Because you look at it this way, it looks strong, but, you know, maximum in-cylinder pressure is really here. So you can see what it's doing
Okay.
here. And that's why you'll see pictures of motors that are blown up. You say, hey, this rod just folded. Well, that's why.
Okay.
Compared to the I-beam style rod, which now it's thicker in areas that resist bending.
Okay.
It has better support at the wrist pin. And we'll see more of that when we get into the stage 3 and higher.
And we're running our stage 1 with a factory OE crank.
That's correct.
Anything special about the one that we use?
It's a forged nitrided crank, so it's, you know, going through a surface hardening process. It's actually a great crank for, you know, what we do. And we, you know, still use that in, you know, we've actually used it in stage 4 short blocks in the past.
Okay.
And before we switched over to the billet cranks, and, you know, it's a economical piece that performs very, very well.
Okay, nice. Okay. Rod bearings and obviously main bearings, what are we recommending and what are we using here?
We use ACL brand, they're race series bearings, you know, they come in various thicknesses, you know, H and HX that everybody's familiar with. ACL for us packages the bearings in flats of bearings rather than in box sets. That way we actually take the bearings and we actually go through them and essentially grade them ourselves as far as their thickness, so that we have total control over our final bearing clearances based on our connecting rod and crankshaft dimensions.
Okay, great. And that's, I guess, something that differs from somebody, obviously. Hey, I want you to build me a short block. Here's my set of rods, set of bearings. We have full control over what measurements and which ones we're going to pair together.
That's correct. But it's also as economical for us in that we're not, you know, purchasing and opening multiple sets of bearings trying to find the sizes that, you know, meet, you know, our criteria for clearances.
Okay. For our stage 1, we're still running OE case bolts?
Yeah, so OE case bolts, perfectly fine. We do put new ones in.
Okay.
Obviously, while we're, you know, prepping the block, you know, final assembly, new, you know, OE bolts are used. Okay. As we consider them a one-time use only.
Okay. And then what about head studs for stage 1?
There we use the ARP brand head stud kit in the stock 11mm size, which is perfectly adequate for this level.
For our stage 1, what kind of power level are we looking at that it can handle?
Stage 1 is rated to 500 brake horsepower. We have tested this and the combination of parts and how we arrived at this combination, you know, to provide value and performance.
I can roll.
someone that's looking at a stage one, what should they really be using that for? Should that just be kind of like a quick replacement to get you back on the road, or?
Yeah, the stage one is a nice combination where if you're in a position where you need to get your car going, you use it as a daily driver, yet you're looking at a performance standpoint and want to add other things, up to the horsepower limit that we rate the short block. It's a nice economical way to get going, yet have a path to grow without having to start over.
Okay. So that probably would have been a good choice for me. I mean, I only was running a Cobb Stage 2 map on my car, turbo back exhaust, intake, and a few other little mods here and there, but nothing crazy. I think I was making 312 horsepower or something like that.
Exactly, and that's also the basis of, that's enough mods to start breaking stock pistons. So here we go with the parts combination that's economical and makes sense.
All right, so I have a few questions that you guys have asked, so we're just going to go ahead and shoot a couple of them off at Jim. Jim, if someone orders a stage one block and they order a oil pump, pickup, and pan, does that come assembled onto the short block already, or is it separate?
Those items are separate. The short blocks, as we finish manufacturing and assembly, are specially packaged in their own boxes for shipping so that they arrive safely, and these other parts are packaged separately and are up to the customer or their shop to install.
Gotcha. Okay. And the short block does come fully assembled?
Yes, it is fully assembled. It has packet of information attached to it with break-in instructions of where to find those and other recommendations.
Which is probably very important to read.
Absolutely, absolutely. It's like anything else that comes with instructions, you do need to read these.
Great. So we recommend that you read through the pamphlet from top to bottom. The stage one block work on a stock ECU?
Yes, no problem running on a stock ECU. Obviously, you've done other things to your car, then you'll also need to modify your tune for that. But this is the intention of this.
Okay. So if I had a fully stock car, needed a new motor, I could pull that out, drop this in, and once I get it running, turn the key and go.
That's correct.
Okay. Next thing we've been asked, can our 2.5 liter blocks work with 02 to 05 WRX 2 liter heads?
Yes, the cylinder head combustion chambers need to be modified as far as the difference to correct the compression ratio between those.
Okay, so it's not a quick just I can bolt them on and we can go.
No, we do have another short block offering that does take care of that.
Yeah, baby, yeah!
Next, we're going to go over our stage 2 block. Jim, what goes into building our stage 2 and how does it differ from our stage 1?
Right, so same procedures, and block and piston are used in the stage 2. What happens between stage 1 and 2 is we add the H-beam connecting rod, and which I showed earlier compared to our stock OE rod here. Here now we've done a piston and a rod upgrade, which obviously builds a stronger, tougher engine and is capable of holding more horsepower.
Okay. All right, so other than stepping up to a different connecting rod, everything is pretty much the same from that point on from our stage 1?
That's correct. Everything else about it and the other parts used, crankshaft bearings are the same.
Okay. And then we step up and we're rating our stage 2 block to 575 brake horsepower, guys. So keep that in mind when looking at the stage 1 or stage 2, what your power goals are, and if you ever plan to expand in the future, you may want to consider stepping up to the stage 2 versus the stage 1. Next, let's go into our stage 2 Tuff and see what are the differences from our stage 2 Tuff to our stage 2 that someone should, I guess, maybe consider if they're already looking at a stage 2 block. Should they go ahead and move to the stage 2 Tuff? What would be the deciding factor and what's different in that block?
Right. Obviously, it's again rated at a higher horsepower than stage 2, and with that, we move in the progression of better parts for it and its design. What we do here, there is a rod change. It's still an H-beam rod with ARP 2000 bolts, but as you can see that we've increased the cross section. So obviously helping with some compressive, strength in the rod, and you can see how it's wider than its stage 2 rod. So again, it's going to be able to take more. Then there's a piston change, both in bore diameter. Here now we bore and hone to 99.75 millimeter. So we got better control of piston wall clearance for this particular piston we've had designed. Now we're stepping up to a box style forward side relief design, and again uses proprietary set of rings that JE provides for us.
You said a box style design. Now what's the difference in between that and what we have in our stage 1 and stage 2?
All right, what we have here is, you can see on the outside it looks generally the same, but on the inside of the dome you'll see there's some extra bridging in our stage 2 Tuff piston relative to our stage 1 and 2 piston. And how these are made, this piston here is actually known as an as forged piston, and it literally is a single strike forging compared to this. It goes through multiple strikes in order to get the different reliefs and the box style design.
Okay.
So it presents extremely strong economical piston.
Okay. And then what are the, I guess, coatings that we have on the pistons here? Skirt coatings?
Yeah, these skirt coatings, provided by JE, they call it their perfect skirt, and it's relatively new in the last couple of years in that it's actually designed to be sacrificial to a point where we're able to install it, still proper piston wall clearance for proper operation, yet the coating is actually sacrificial in that it is used and wears itself in. So this is what helps us provide, quiet running motors at idle instead of you don't hear piston slap.
What?
Slap! Now, besides the piston change and the bore and hone on the block and obviously the rod upgrade, is there any other major differences in the stage 2 Tuff versus stage 2? Case bolts?
No, case bolts are still OE again.
Okay.
No, it's really just a larger cross-section H-beam and a different piston and bore size change.
Okay. Just to handle a little bit higher of a power level.
Correct. We're still within the limits of the OE open deck block and crankshaft.
Okay. We're diving into our first closed deck block, which is our stage 2.5. And not to get that confused, all our blocks that we do are 2.5 liters. This is just our stage 2.5.
No, in addition to the EJ25s, which are 2.5 liters, we also do the FA engine family, which are 2 liter based for the DIT and the BRZ series, as well as we've just started building 2 liter EJ20 line of short blocks.
Okay, with that being said, Jim, what is the difference between a stage 2.5 versus our 2 Tuff?
The most notable thing is the stage 2.5 is the closed deck cylinder support system. Stock block is an open configuration, and it does have some support points in it from Subaru, but for what we do in performance use, the cylinders still move around and won't stay round under higher boost and higher pressures. So our system encloses all of that and helps negate cylinder cracking, which the stop blocks are known for, especially next to some case bolt holes that are relieved for clearance for the bolt holes, which actually makes it thinner in that one area. So this helps negate a lot of that.
Now, one thing we get asked a lot with our closed deck blocks is, do they overheat? I'm not sure why that would be a question that we get asked a lot. I mean, I guess I can understand that with us closing up some of the block to where coolant flows through. But I mean, it looks like we're still allowing coolant passages in our closed deck block for proper function, I guess.
That's correct. Obviously, the most noticeable difference, as you said, is obviously we've closed off the deck compared to the stock block, which is all open.
Yes.
The water flow is actually controlled more by the head gasket itself. So if we overlaid this over, you'll see where the stock coolant holes are, and we've put holes in our inserts for water to flow through these, and this actually even covers up some of the holes we provide. So the head gasket is actually controlling water flow in the block and to the cylinder heads. So you can see how much compared to open deck block, stock block, this closes off a tremendous amount of it.
So still, even with a stock block, we're still, once we put the head gasket on, we're closing some of that area that coolant would actually be able to flow through, that it's still only getting through holes in the gasket to the head.
That's correct. The open deck system that the OEs use is cost savings and manufacturing ease.
So they're fine for people to use in their daily drivers then.
Absolutely.
So Jim, what is the major difference between our 2 Tuff and our 2.5 for internal components?
For going up to the 2.5, we go and step up to the little beefier H-beam rod compared to the one we use in our Stage 2 Tuff, and complement it with thicker wall wrist pin. The 2.5 uses a 210-inch wall thickness pin. It's also 9310 steel.
Okay. So still same piston as our 2 Tuff.
Yes.
We're just beefing up the
wrist pin in the rod.
Wrist pin in the rod. Okay. Same stock crank that we're using.
Same crank, same bearings.
Okay.
You know, clearances are adjusted for, you know, as the horsepower goes up.
Okay. How do these hold up? I guess if somebody wants to make around 500, and they're going to do a little bit of track days here and there.
Well, that's, you know, one of the purposes, you know, going with this stage of closed deck, where it's a nice combination of street and track day use, as far as, you know, good parts that can withstand higher performance and some of the rigors of track days,
Okay.
yet still be at home as a daily driver on the street.
Okay. Are we changing anything with case bolts or head studs for this block versus the 2 Tuff?
No, like the 2 Tuff, this still continues to use the OE case bolts, which are more than capable at this level.
Okay.
And likewise for the standard 11mm head studs.
Okay, from ARP. We have our Magnum block here. Jim, what is major differences between this and our 2.5?
All right. The block, it still uses our Stage 3 closed deck cylinder support system.
Okay.
And now we step up to a 14mm diameter head stud.
Okay.
Which can take, you know, is obviously torqued to, you know, a higher spec and provides more clamping, you know, pressure, you know, on the head gasket.
Okay.
You know, which equals, you know, less chance of lifting a head. Biggest thing is now we
lifting a head, you're actually talking about the head separating.
it tries to push it apart and separate the head from the block.
Okay. Wow.
And that's where we're trying to use different gasket systems to
Okay.
help with the seal. It's going to move to some extent, so with more, you know, power and combustion pressure, it wants to move more, so we need to step up in, you know, head stud and clamping to resist that.
Okay.
Notable difference is we step up to what we call our Firelock head gasket system.
Okay.
Which consists of, we have counterbores in the block, and we manufacture these stainless steel fire rings that are set into the groove, so they have support on the outside as far as outward combustion pressure, rather than it being sent to the edge of the head gasket. Yeah, so we have, you know, fire ring that basically provides all the combustion sealing, and then the head gasket is used for sealing as far as water and oil. So it does not see any direct compression.
Okay. So versus when we use the JE head gaskets, they're seeing.
Right, there's nothing, you know, preventing them from being exposed on their edges to, you know, into the combustion chamber and the cylinder bore, so they see, you know, all of that, you know, combustion heat.
Okay.
And pressure. Whereas, you know, this gasket doesn't see any of that. All of that is absorbed by this ring.
Gotcha. Now, what is the difference in the gasket that we're using versus the gaskets that we use in our other stage blocks up to this?
The other gasket which we showed you are a multi-layer steel head gasket that, you know, has been embossed with, you know, what we call a fire ring around the cylinders, as well as some other areas for sealing water and oil passage. And they're multi-layer, you know, anywhere from, you know, 3 to 5 layers, depending upon brand of gasket.
Okay.
You know, it's a perfectly fine sealing system. We start moving up in power, then we have to upgrade that.
Okay.
And this is the next step in that process.
Gotcha. Any upgrade in the rods?
Yeah, with our Magnum rod, it's the same style H-beam, except in 625 plus ARP rod bolts, but we run a 2mm longer rod.
Okay.
You know, improves the rod ratio with the motor, you know, as far as RPM, and, you know, changes piston speed and load on the piston, and which also means we have a different piston as far as the wrist pin has been raised up in the piston closer to the oil ring.
Okay. So that's one question I have had is when you say a +2 rod, I'm thinking the rod's longer, it's going to protrude the piston out longer, but they have moved, now you said the wrist pin hole up.
That's correct.
To compensate for that.
Correct. The wrist pin hole is moved up a corresponding amount closer to the dome of the piston.
Gotcha. Okay.
So like if the piston's at top dead center, it stays there. So they move that hole up and then put a longer rod in.
Gotcha. Okay. That's
The
one thing.
position of the piston in the cylinder hasn't changed any.
Okay. That's one thing I always thought when you guys say we're running +2 rods in this one. I'm thinking, well, aren't they going to protrude out of the deck? So do we have to modify the head, or
Right. Thicker gas.
they're modifying it on the piston there?
Right.
Then? Okay.
Correct. It's a corresponding change.
And same wrist pin as the
Same
Trojan?
wrist pin, that's correct. Still the 210, 9310 steel pin.
Okay. Now I see that we're rating this block to 900 brake horsepower, which is calculated pretty much out to around 700 to 720-ish wheel horsepower.
Right.
Who would we say this block is suited for?
This is for a serious track day guy who still has a streetable car.
Okay.
It's well suited for like your time attack, track day. You should certainly drag race with it, street race with it. Yet it's still streetable.
Okay. We have our Stage 4 Tuff here laid out on the table. So let's go ahead and get into this one. Jim, what's the difference between this and our Magnum block?
Okay, we carry over a few pieces, but the biggest change is now we move up to our Stage 4 style closed deck support system, which adds threaded plugs in the 8 locations for the case bolts through the deck surface. And what that amounts to is, here's an example of our plug. Each one is engraved for not only which side it goes on, but a specific location. And there's marks also that get lined up as it's machined with the plugs installed. That way you can remove them for access to the case bolt and get these plugs back in their respective locations and torque to correct specification.
Okay. So each one of those, I guess, markings that I'm seeing on here.
Yeah, it should be like a right and a left and a number 1 through 4.
Yes.
For each side.
So these don't come, do we pre-install these?
These are pre-installed. They're dedicated to each block. They don't interchange. If you lose them, we need your block back so we can insert new ones, re-deck the surface, re-engrave.
Okay. All right. That's good, something to know. And then obviously appropriate torque will line both of those markings up.
That's correct.
You're in line. Okay.
Right. Other than that, it carries over from the Magnum as far as the 14 millimeter head studs and the Firelock gasket sealing system. Then as far as internal parts, I-beam connecting rod uses the +2 long, similar to the Magnum being +2 long, but we upgrade to I-beam style.
Okay.
Piston upgrade, much like the Magnum piston, same similar side relief, box style. Has the end plating, which at this point now includes all the way down to the O-ring land.
Okay.
Another feature is we upgrade to lateral gas ports for the top ring, which helps with sealing.
Okay.
And the piston also obviously is +2 designed to match the rod length.
Okay. Same pin in the Magnum, or does that get upgraded as well for the 4
No, same. This does have a pin upgrade also, good point. It uses a 250 wall thickness wrist pin, also in the 9310 steel.
Okay. And then same OE crank for our 4 Tuff?
Yes, so at this point here, we're still using the standard OE crank, which is perfectly fine for this application.
Okay, and then looks like we rate our 4 Tuff guys for 1,000 brake horsepower. So you guys that are looking to make a higher power, definitely want to start looking in the Stage 4s. Anything else we need to touch on, Jim, for the Stage 4?
No, that pretty much covers it.
Okay. We have our Stage 4 Extreme laid out here. Jim, what are the differences from our Stage 4 Extreme versus the Stage 4 Tuff?
Okay, Stage 4 Extreme, again using the Stage 4 style closed deck system with the threaded plugs, as well as the Firelock head gasket sealing system. Block-wise, we add pinning of the mains, which are steel pins we insert in the number 2, 3, and 4 main webs that help maintain the alignment between the 2 case halves. And to also help with that, we also upgrade to an ARP case bolt kit so we can increase clamping force on that, again, to help holding the 2 halves together, keep them in alignment to compensate for additional pressure and horsepower being made.
Okay. Still same +2 rod?
Still have the same +2 I-beam rod with 625 rod bolts. The change with the rod is we upgrade from a 906 thou wrist pin to a 927 thou wrist pin, as well as still the 240 wall thickness, but we also upgrade the material to an H13 steel.
Okay.
As well as the piston is the same, as the Stage 4 Tuff, other than +2 and a 927-inch.
Okay. I can tell right away that the crankshaft is different from the OE one.
Right. We also upgrade to a billet steel crankshaft in the same OE 79 millimeter stroke, so that doesn't change. So it's still a 2.5 liter.
Okay.
So besides being better material, stronger crank, the oiling in it is different than the OE crank. With the billet crank, we're able to dedicate one main oiling one connecting rod, whereas the OE crank, the number 3 main, the one main actually feeds number 2 and 3 rods. So it's trying to feed 2 rods through one hole. So the oiling with the billet crank is better suited.
Okay, for a higher horsepower.
For higher horsepower and the requirements of oiling.
Okay. And this would most likely be a setup that, I guess, guys that are looking to put fast times down the drag strip would be running this.
Yeah, this is your go-to short block for serious drag racing.
Okay. I think that pretty much covers it for our Stage 4 Extreme here. Next, we're going to move on to the one I'm sure everybody's been waiting for, our Stage X block.
X gon' give it to you. He gon' give it to you. X gon' give it to you.
Jim, what are, obviously the case is a major difference, but what else are we looking at that's different here versus our Stage 4 Extreme?
Internally, as far as the internal parts, it's those parts are identical to the Stage 4 Extreme as far as the billet crankshaft, ARP case bolts, the I-beam rod, 625 bolts, and a 927 diameter pin.
Okay.
Likewise, the matching pin and piston that go with that. So block-wise, the biggest difference is, obviously it's billet, and there's no threaded plugs or anything like we use in the OE cases for our Stage 4s. So we have total control over how we make it. We're able to leave material for strength in places where we feel are weak in the OE case,
Okay.
as well as more material for like larger fasteners, such as the fasteners going around the perimeter of the case are larger than OE, so we're able to provide some better clamping and stability there. There's also some bosses internally, so we can add some bolts there that are not at all in the stock case because there's no place
Okay.
to put them. So the advantage of billet is it allows you to start with a somewhat clean slate to add things, features that you can yet still fit within the package that fits in the car, and as well as the other pieces that bolt to it.
Okay.
The block is also features a flange step sleeve.
Okay.
It's thick wall sleeve. These are capable of going over 100 millimeter in bore size and still safely run. These
Now do we bore it to 100 millimeter?
No, we can start off at 99.5 millimeter.
Oh, okay.
So we can actually go with an OE size. We don't, because the 927 wrist pin and all of our pistons are made 9.75 millimeter for that. So we do go straight to that, but you have room to grow
Okay.
with the sleeves, and the sleeves are replaceable.
Interesting.
Which is nice. It's semi-finished from the manufacturer in that it does come with the 14 millimeter head stud holes. We have to set the deck height for our piston crank rod combination, add our Firelog groove machining
Okay.
for the head gaskets, and we also go back through the main bore after assembling with the ARP case bolt kit.
Okay. And it's gold too.
It's gold.
Everybody loves gold. Okay, now Jim, what would be, I guess, the overall advantage versus our Stage 4 Extreme? Because obviously when people look at this case half or the stage block and see the price difference between our Stage 4 Extreme, I guess also who would this block be more suited for?
This would be the next step up as far as, say serious racing. In fact, that obviously the block is stronger with the flange sleeves being thicker wall. There's some more stability there. As we add, more pressure.
Okay. Someone doing drag racing just be looking at this block, or would someone doing road racing also, would this be something suitable for them? Or
It'd be suitable for, basically any application. I mean, you
Okay.
could run it on the street and it'd be perfectly fine.
Okay, all right. And then, as you did say, the sleeves are replaceable. Obviously, they look like they're made out of a different material as well.
They're made out of ductile cast iron.
Okay.
And as far as a need to replace them is, once it's been bored out, to its max, as far as its next rebuild, instead of replacing the block, as we
Okay.
do with our OE cases, we can just change the sleeves and we can start all over again with another set of pistons and work our way up, through the various oversizes as needed for future rebuilds. So this has, potential for longer life expectancy.
For racing and
Right.
if you're doing that type of heavy stuff with the.
If you damage one sleeve or one cylinder, you can replace just that sleeve. You don't need to replace the entire
block. Okay. All right. So that's something to think about, guys. For you guys that are trying to build a serious drag race car or even a road race car, this might be the suitable option for you with, expansion to grow down the road, and anytime that a repair would need to be made, it's going to be, I guess, a lot less or a lot more cost effective.
In that aspect of it, as far as, you can, as long as the block itself is structurally sound to support the sleeve, there's no reason not to continue using it and just replace sleeves as needed.
Okay. Okay, guys, that's a look at all of our stage blocks on the EJ series. So as you can see, we offer anything from stock power level up to 1100 plus horsepower. Jim, appreciate you joining us and giving us a rundown of all our setups here.
You're quite welcome.
I hope this answers a lot of questions for you guys. If you guys have any further questions, please contact our customer service representatives, and we'll catch you guys in the next video.